Okay, let us begin. So, first one, if you haven't done it, take a moment, try to figure it out. Tell me what the answer is. First one to get it right wins a free donut. Aha. Somebody jumped in there. 16. Yeah, I like that. Okay, so the logic on this one, remember, what happens first? Multiplicative operations going left to right. So the division happens first, then the multiplication, and then the addition of those two quantities. So 6 divided by 4 is 1 in Java, 3 times 5 is 15, and 1 plus 15 is 16. Hey, dog. All right. Next one. Take a minute, solve it. Or if not, you can enjoy the view of my dog. Say hi, Indy. All right. Good boy. Let's see. You're okay, buddy. Okay. All right. Correct answer on this one. Same as the first, right? It works the same way. So multiplicative operations left to right. So 1 times 4 is 4. 2 divided by 3 in Java is 0. 4 plus 0 is 4. Okay, last one. Take a minute. Solve it. No. Okay, so what happens first on this one? Parentheses first, right? And then the multiplicative operation. So 3 plus 5 is 8. Then 1 times 8 is 8. 8 divided by 5 in Java is 1. Okay, questions on any of those? Okay, so for those who missed it, correct answers were 16, 4, and 1. Okay, so those are the easy ones. Let's move on. Okay, first one. Take a minute. Solve it. All right, come over here, dog. Yeah, all right. Okay, so this one, remember, key thing to remember, it is a double, but it's only a double after all the action on the right happens. Okay, so the stuff on the right is going to be calculated the same way regardless of where it ends up. So all of those numbers on the right, they're ints and they act like ints. So what do we do first? 2 plus 3 is 5, right? We do the stuff in parentheses. Then left to right. So 4 times 4 is 16. 16 divided by 5 is 3. Okay, it's not 3.2 because we do this full math thing here before we assign that quantity to D. So this evaluates to 3. When we assign it to D, it becomes 3.0 because it's a double. Okay, second one, take a moment, solve it. Okay, this is an easy one if you understand how the whole mixed expressions work. So 9.0 times 3, that's 27.0, right? You're multiplying an int by a double, so the result will be the highest precision type, which is double. Then 27.0 divided by 5, well, 27.0 is a double. Divided by 5, you get 5.4. Since one of the numbers is a double, then the whole thing acts like a double. And then we assign that value to D. So D is 5.4. Third one, take a moment and solve it. Okay, so parentheses first, right? 2 plus 3 is 5. Then 5.0 times 7, mixed expression, so it's 35.0. 35.0 divided by 5 is 7.0. So we assign 7.0 to D. Okay, and the last one. Last one's a little tricky. So we'll see who knows their Java stuff. Yes, if you guessed 0 or answered 0, that is correct. That is good. Okay, reason is stuff in parentheses first, 2 plus 6, then it's left to right with the two multiplicative operations. So 4 divided by 8 in Java, that is 0. 0 times 2.0 is, of course, 0.0, which we assign to D. So on an exam, you know, the correct answer would be 0.0, but I don't usually try to trip people up like that. You know, the difference between 0 and 0.0. But D is a double, this is a double, so it should be 0.0. Okay, questions on any of those? Nothing? We're all good? Everything makes lots of sense? Ah, see what we got here. Yep, okay, good. I mean, if things make sense to you, that's great. That's wonderful. However, if things don't, then you're really the people I want to hear from. All right. Well, let's move on. Okay, some more practice problems. Why don't you give the first one a try? Okay, let's see what we got here. I don't know, my chat window's not appearing. Maybe something vanished. There we go. Okay, some people, we have a variety of interesting numbers here. Well, let's take a look at it. Okay, so this first one, right? What do we do first? The stuff inside the parentheses. Well, it's all inside parentheses, so we have to do all that first. And it's multiplicative, so it goes left to right. So 6 divided by 4 in Java is 1. 1 times 3.0 is 3.0. We typecast it to an int, it becomes 3, but when we assign it to D, it gets automatically promoted to a double. Thus, it's D equals 3.0 after the end of that. Okay, so correct answer, D is 3.0. Next one, give it a try. Aha, we have a 4.0. Well, let's take a look at that. 6.0 divided by 4.0, that's 1.5 because they're both doubles, so we do math the normal way. 1.5 times 3 is, of course, 4.5. When we typecast it to an int, it becomes 4, and we assign it over to D, it becomes 4.0. Yep, so correct answer, 4.0. Okay, so when you evaluate this stuff on the side, yeah, it turns into 4, but when we assign it to D, it's 4.0 because it's a double. So with ints, with integer types, of course, you never show a decimal portion, but with floating point types, you always show a decimal portion, even if it's just 0.0. Okay, last one. This one should be easy if you've completed the other two. All right, let's take a peek. That sounds right. 9.0 divided by 2.0 is 4.5. 4.5 times 1 is still 4.5. 4.5 plus 4 is 8.5. We typecast it to an int. We throw away the fraction part, so it's just 4. And when we assign it to D, it's 4.0. Okay? So if my memory is correct, and it usually is about 50-50, D was 3.0, this D was 4.0, and this D was 8.0. Okay. Questions on those? All right, so like a lot of things in life, I imagine it's pretty easy when you just see somebody there doing it, but, you know, people do make mistakes on this. Okay, moving on. Trying to move on. There we go. Couple of modulo problems. So, what's 14 modulo 5? Let's see what the chat window says. Let's see what it has for us there. Aha, an interesting guess, 4. Is that correct? Well, jumped ahead there. Anybody else? Okay, because there's a valuable teaching moment if somebody gets the wrong answer. But, all right, what do we have here? Yeah, so we got a few 4 and 8. That's a strange number. Okay, so the correct answer is 4, but I'm going to explain this in Notepad. Okay, so 14 modulo 5. We know 14 divided by 5 is 2.8, right? So many students would say 0.8, but that's wrong. Okay, remember modulo gives the remainder after division, right? So 14 divided by 5 equals 2 with a remainder of 4. Correct answer is 4. Okay. So I hope that explains this. Okay, so the first one, correct answer is 4. So let's go back to the slides. Let's see, we got something in chat there. Oh, practical example of modulo in Java. Well, one example is checksums. Okay, it's not the only place where they're used, of course, but imagine, okay, I'll write this up in Paint. Paint is your friend. In case you haven't figured that out yet, Paint is definitely your friend. Okay. Suppose you have a very large sequence of data you're sending, okay? Very large sequence of data. And it's grouped in sets of 4 bytes, right? So there's a whole bunch of little 4-byte things. It's all a stream of data, but, you know, 4 sequences of 4 bytes, okay? Now, if you wanted to quickly check that the data all arrived safely and correctly, how might you test that? Well, the answer, with a checksum. So essentially, you add up all the 4-byte quantities and discard all the excess bits above, right, 4 bytes. Decimal equivalent would be like you add up all the numbers, but you only keep the lowest, say, 8 digits, 9 digits, whatever, okay, of the sum. And that's basically what modulo is, right? You add up all these things, you convert it modulo this, you know, 32-bit, 2 to the 32, keep everything on the side. Now, it's not guaranteed to give you, absolute certainty about data integrity, but it's pretty good since there's only a 1 in 4 billion chance that you randomly get, the wrong but correct answer. Okay? Basically, there have to be a whole bunch of things go wrong in your system, and then you somehow randomly say, oh, yeah, but the total still lines up, right? It would be very unlikely. Number one, it's very unlikely that a whole lot of things go wrong in the data transmission. I mean, sure, you might have a bit here or a bit there occasionally go wrong, but the chance that a whole bunch of them go wrong, and they go wrong in the 1 in a 4 billion chance possibility that it doesn't get caught by the checksum is pretty unlikely. Okay, there's lots of other places where modulo is used. For example, if you're doing encryption and you want to multiply a number by some amount but keep it fit to the same number of bits, modulo is good for that as well. Okay, but checksums are easier to explain. All right, good. So we got a little side content in here. That's fine. Yeah, checksums. Okay, other stuff. Anybody questions on any of these sample problems then? We're all good? I guess we're all good. I would have heard from you by now if we weren't. Okay, so next modulo one. X is 6, Y is 2.5. What's X modulo Y? What's 6 modulo 2.5? One. That is correct. Okay. So if you got 1, then that is correct, and all is well with the universe. Okay. Reason is 6 divided by 2.5. Well, 2.5 times 2 is, of course, 5. So 6 divided by 2.5 is 2 with a remainder of 1.0. So the correct answer is actually 1.0. And this is a strange thing I should mention with modulo, with some of these other operators as well. It doesn't always work the way you would think it would because of the promotion. So sometimes the typing rules get a little bit, they get a little bit broken, right? Because X is an int. This quantity, should be an int, right? Because X is an int. But no, when you evaluate it, the promotion applies to the modulo process as well. It's as if it turns X into a double so that it can do the modulo operation with Y and thus returns the result of 1.0. So depending on your point of view, it's breaks it or doesn't. But what makes it interesting, right? We say X modulo equals Y, we're automatically fitting this result to type X. So that's a little bit odd. Okay, because we can't assign 1.0 to X. We can assign 1 to X, but we can't assign 1.0. All right. You'll see if I do this in Eclipse, I guess I should have had Eclipse up already. Get that. I'll show you some modulo stuff in a minute. Okay. So last batch of problems. So this first one, what's M? M. Okay, I'll flash it up there again, then you guys can see. Okay. Well, let me know when you get it. Okay. Anybody? Correct answer? All right. Well, the correct answer is 10. Okay, we'll walk through that. So first, m equals 32. Okay, so that's fine. M is 32. Now, you know what? I'm going to lift this and put it in Paint so I can edit it a little bit easier. Oh, there we go. Yeah. I just need to be bigger and larger. It shows up in that font. Arial black. Boom. Okay. You can be a little bigger. Okay. Damn it. This is harder than it looks. All right. Come on, you. Sure. Let's try this. Damn it. Last time's the charm. Okay, so we're just going to do this. And I'm going to grab it again because I'm not sure what's going on here. Paint doesn't want to play today. See, now why? All right, forget it.
You gotta change the color, Professor. I don't think you've changed the color of the font.
Yeah, but the color's black. Oh, you're right. The color's white, isn't it? That bad. No wonder. Yeah. Okay, it's white in the slides. Yeah, good call. Thank you. All right. All right, it's freaking me out. All right, last time. There we go. Thank you. Okay. Okay, good. So I'm going to put in some notes on the side here. So this one, of course, right? M equals 32. That's great. Next one. N equals 32 modulo 6 equals 2. Yes. Okay. 32 divided by 6 is 5 with a remainder of 2. Here we increment n, so n equals 3. And here we have m equals int, first of all, okay, double m. Okay, m is 32 divided by n is 3. Okay, 32.0 divided by 3. Okay, which m equals, you know, int of basically 30, right, divided by 3. If we just want to do it without getting the calculator, right, it's going to be 10, right? It's going to be 10 plus a bit, okay? Thus, m equals 10. Correct answer is 10. Okay. Next one. What's C? All right, let's walk through it. So, I'm going to just lift that text again. It's weird. Okay, there we go. Okay, so first step here, okay, A is 5, B is 5. Ta-da. Okay, down here, B plus equals 18, thus B plus 18 equals 23. Okay, because B was 5 up ahead of the step before that. B modulo equals A. So B equals B modulo A equals 23 modulo 5 equals 3, right? 23 divided by 5 is 4 with a remainder of 3. And then the last one here, C equals A plus B. So C equals 5 plus 3 equals 8. Okay. Yep. Okay. Questions on that? Questions on any of these math examples?
So whenever you have a
Yeah.
variable, like we have b here, and you just put like a symbol next to it, like you put addition or division or something, does it mean that it's doing that to itself?
Yes.
Okay.
Yeah, if you look back at the slides here, if we go back a few, right? We covered that here in the, right there, basic arithmetic syntax. So they're what are called implicit operator assignments. Okay, basically what we mean is we're doing it to the number itself. Okay, so like this is x adds 1 to itself. This x subtracts 2 from itself, that sort of thing. Okay.
Awesome. Thank you.
You're welcome. Trying to get to the chat here. Let's see. It always hides behind never mind. I got it. Good. Okay. Good. Well, you got it then. Okay. So that's it. That's it for numeric variable stuff. So I'm going to stop this recording. And